Hello mathematicians, today we're going to be looking at fractional distance on a coordinate plane. Okay, an ice cream truck driver has found that she can maximize her profit by parking as close to the local school as possible on either Elm Street, which leads to the nearby school neighborhood, or on Main Street, which leads to the nearby park. There is a city ordinance that say retail vehicles must park their trucks no closer than 1/5 the distance between the school and a neighborhood, and 1/4 the distance between a school and a park. What are the coordinates if the truck is parked on Main Street? What are the coordinates if the truck is parked on Elm Street? All right, so my first question talks about Main Street, if we're parked on Main Street. So that is going to be this street right here, okay? So when we're parked on Main Street, and I know that Main Street leads to the park, and we can't be more than 1/4 the distance between a school and a park, and we want to be as close to the school as possible. So 1/4 from the school to the park, okay? Well, let's see, how far is it from the school to the park? Since it's vertical, we can just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we know the total distance from Main Street to get from the school to the park is 16. We are going to go 1/4 of that, right? 1/4 of this total 16. Okay, so then if I'm going to go 1/4, that means I'm just going to go 1/4 of 16, which is 4. So from the school, I'm just going to go down 1, 2, 3, 4, and I'll end up with parking my truck right here, which has an x value of 7 and a y value of 5. So the coordinates I would park at if I was going to park on Main Street would be the coordinate 7, 5. Okay, so then it says, well, what if we park on Elm Street? Elm Street leads to the nearby neighborhood. So Elm Street, 1/5 the distance between the school and a neighborhood. So when I look at this street here, I want to go 1/5 the distance along that diagonal. Now when we do the distance along a diagonal, we have to look at the vertical change, and then we also have to look at the horizontal change. So just to kind of clean up my picture a little bit, I'm going to delete what we did, the work we did here, for the first part of this problem, so that we kind of have a clean slate for the second part. Okay, I can still see I left the point where I'm going to park. Okay, so now we're first going to talk about what our vertical change would be. To go from the school to the neighborhood, that is going to be a vertical change of still, just like before, we're still going to be going down 16 units, right? We can't go more than 1/5 of that. So just like I did before, instead of 1/4 of 16, now we're going to do 1/5 of 16. So when I do 1/5 of 16, 1 divided by 5 times 16 as a decimal, that's going to be 3.2. So I know I'm going to go down 3.2 but kind of along the diagonal. You'll see what I mean in just a moment. Okay, so then what we're going to do is we're going to look at, well, how far left then? What is my amount change to the left, my horizontal change, if you will? Okay, so when I count that one, because we haven't counted that one yet, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and remember we can only go 1/5 of that. So 1/5 of 12, 1 divided by 5 times 12 as a decimal is 2.4. Okay, so I know I'm going to be going back from this point, I'm going to be going back 2.4. Okay, so I need to figure out how far do I end up if I go down 3.2, if my vertical change is 3.2, and then my horizontal change is I'm going to go back to 0.4. Okay, where is that going to put me? Okay, so what I need to do is think about, well, what were my original coordinates for the school? My original coordinates for the school, the original coordinates right here for the school are at 7, 9. I know I'm going to go down 3.2, so that affects my x-axis. For my x-axis, I need to, or sorry, my y-axis when I go down. So I'm going to change, I'm going down, so that's subtracting from the y value, 3.2. And then I know I'm going to go back left, so that's when you move left on a graph, you're subtracting. So I'm going to subtract, I'm moving left 2.4. So let's see what our new point is going to be. Our new point is going to be 7 minus 2.4 is 4.6. And 9 minus 3.2 is 5.8. So this is where I'm going to park my ice cream truck to be 1/5 the distance between the school and the neighborhood. So at 4.6, that's a little more than halfway between the 4 and the 5. And then 5.8, that's almost all the way up to the 6 on the y-axis. So we can see it's going to intersect right about here. Okay? So I'm going to be at 7.5 for if I park on Main Street. And I'm going to be at 4.6, 5.8 if I'm going to park on Elm Street. Okay? All right, so hopefully that helps you looking at fractional distance on a coordinate plane. Thank you so much for joining today.